Hello students. So far you have studied so many topics, and today we will start with the topic optics. More precisely, it is ray optics. And the basics of these ray optics you had already studied in your lower classes, and we will consider those concepts once again. And let us refresh all the concepts what you have studied in your lower classes, and we will study a little more. And every day you see the phenomena of reflection, refraction, and you observe the phenomena of interference, diffraction. More precisely, you will observe the diffraction phenomena more than the interference phenomena. And about all these things you are going to study in the coming topics of optics. The first topic is ray optics, and the next topic is wave optics. So, in these two topics you will be studying most of the phenomena, and you will become thorough with these concepts. And you know that optics is a branch of physics which deals with the light. So, the phenomena or the branch which deals with the light, that is called optics, and you branch these optics into ray optics and wave optics. One is ray optics or the geometrical optics, ray optics, or that is also called the geometrical optics, and other one is wave optics. And you observe the phenomena of reflection, you observe the phenomena of refraction, you observe the phenomena of interference, you observe the phenomena of diffraction. And if you ask the question why there is reflection, why there is refraction, why there is interference, why there is diffraction, usually these geometrical optics or the ray optics that will not give you the satisfactory answer why that phenomena is taking place, but it is wave optics that gives you the answer for the question why there is reflection, why there is refraction, why the interference takes place, or why the diffraction takes place, and the satisfactory explanation would be given by the wave optics. So, shortly you are going to study about these wave optics. Now, you know the visible range of light for the human eye, but directly you cannot see the light. You will see either the reflected light or the refracted light, and so on. Directly you cannot see the light, and the visible range of the light is from 400 nanometer to 750 nanometer. The light having the wavelength in that range of 400 to 750 nanometer, that is visible to the human eye. And when we consider this ray, what is ray? Optics is a branch of physics which deals with the properties of light, and this ray gives you the direction of propagation of light and is represented by a straight line with an arrow mark. So, ray gives you the direction of propagation of light. So, if you see a ray like this, or if you see the diagram like this, and if you assume it to be the light which is propagating in a particular medium, you can say that the light is traveling from left to right. So, it gives you the direction of propagation of the light. And if you say the diagram, if you see the diagram like this, then you can say that the light is traveling in this direction. That means the source is somewhere located here, and from that source the light is emitted, and you will have the rays which are propagating in this direction. On the other side, if you see the diagram like this, you can say that if it is related to light, then you can say that the light is traveling from right to left. So, the ray gives you the direction of propagation, it just gives you the direction of propagation. And we will study some important definitions here, like the medium could be either transparent medium, So, when you consider a medium, the medium could be a transparent medium. So, what is the transparent medium? So, the medium which allows light to pass through it, any medium which allows light to pass through it easily, that is said to be the transparent medium. You know the example for the transparent medium, that is air is a transparent medium, or you can consider glass or vacuum, you can consider vacuum also. So, they are all the transparent medium which allows light to pass through it. Then you can consider the opaque medium. The medium could be an opaque medium, and when you consider this opaque medium, this does not allow light to pass through it. The medium which does not allow light to pass through it, is called opaque medium. The example for the opaque medium is wood. Wood is an example for opaque medium which does not allow light to pass through it, or you can consider metal. Metal also does not allow light to pass through it. Then you can consider the translucent medium. So, a medium which allows partially the light to pass through it. The medium which allows partially light to pass through it, is called translucent medium. The example for translucent medium is paper. Paper is a translucent medium, or the plastic. So, they will allow partially the light to pass through it. So, that is called the translucent medium, and here I use the word light. So, what is light? So, the one which produces the sensation of sight. So, the one which produces the sensation of sight, that is called light. The one which produces a sensation of sight, that is called the light. You can also consider the isotropic medium. Then there is one more medium, that is anisotropic medium. So, these are all the basic definitions that you need to know, that would help you some way. So, isotropic medium is a medium in which the light travels with same speed in all the directions. So, here light travels in isotropic medium, light travels with the same speed, in all directions. So, whatever the direction that you consider, you know the Cartesian coordinate system. In a Cartesian coordinate system, there are 3 axes. One is the x axis, the other one is y axis, and the third one is z axis. And these 3 axes are mutually perpendicular to each other. The light may travel along the x direction, or the light may travel along the y direction, or the light may travel along the z direction. Whether the light travels along the x direction or y direction or z direction, the speed of light will remain the same in all the 3 directions. So, the medium in which the light remains the same in all the directions, that is said to be the isotropic medium. Glass is an isotropic medium where light travels with the same speed in all the directions. So, that is an example for isotropic medium. Now, with the definition of this isotropic medium, hope you understand what is anisotropic medium. So, in an anisotropic medium, the speed of light is different in different directions. If the speed of light is different, in different directions, then such a medium is said to be anisotropic medium. If the light travels along the x direction, then there will be one speed. If it travels along the y direction, then there will be some other speed, and if it travels along the z direction, the speed may be different. Such a medium is said to be anisotropic medium. Or there may be two axes where the light may travel along the may travel with the same speed, and in some other axis velocity or the speed of light may be different. So, if the light travels with different speed in different directions, such a medium is said to be anisotropic medium, and the example for anisotropic medium is calcite. Calcite is an example for anisotropic medium where the speed of light is different in different directions. And in certain crystals, the double refraction takes place. Double refraction takes place where the incident light that gets split into the ordinary ray as well as the extraordinary ray, and such a medium is an example for an isotropic medium. And this ordinary ray that obeys the laws of refraction, and the extraordinary ray that will not obey the laws of refraction. So, in that case the speed of light is different in different directions. The incident light that gets split into ordinary ray and the extraordinary ray. Usually that phenomena is called double refraction, and the medium in which the double refraction takes place, that is an example for anisotropic medium. Hope these concepts are getting clear to you. Then when we deal with these optics, we will come across the term like source and image. Source and image. So, what is the source? What is the natural source of light? That is sun. Sun is a natural source of light, and the object which gives out light, that is actually called the source. And when the light from the source is incident on a medium or any surface, either the reflection or the refraction takes place, and due to that reflection or refraction, those rays after undergoing reflection or refraction, they meet or they appear to meet. They actually meet at a point or they appear to meet at a point. So, when those rays meet or appear to meet, then the image of that object will be formed. So, after reflection or refraction, the image of a given object will be formed. So, when we consider the object, which is nothing but the source itself, which gives out light, and this object could be either a real object or it could be a virtual object. The object could be a real object or it could be a virtual object. Now, when do you say that the object is real? Now, suppose you consider the source, say for example, the rays which is coming out of the sun or the bulb, or if there is a candle, then the light is coming out of the given source, right? The light is coming out of the given source, and whenever you deal with the ray optics, this ray is very important. So, you have to draw the arrow mark. So, here the light is spreading or the light is coming out of the given source, and if the light is coming out, then such a object is said to be the real object. If the source gives out light, or if there is a divergence of light, the rays are coming out of the given object, hence that is said to be the divergence, and when there is a divergence of light, then the object is said to be the real object. And on the other side, if the rays they meet at a point, if the rays meet at a point, then if it acts like the source, then the given source is said to be the virtual object or the virtual source. If the rays converge to a point, then the object is said to be the virtual object. Similarly, when we consider the image, if the rays after reflection or refraction, the rays undergo reflection or refraction, and after undergoing reflection or refraction, if these rays meet at a point, if you see this point, these 4 rays are meeting at a point, and when these rays meet at a particular point, they form the image, and the so formed image is said to be the real image. If the rays after reflection or refraction, if they meet at a point, then the image is said to be the real image. On the other side, if the rays after reflection or refraction, if they converge from if they diverge from a point, if the rays after reflection or refraction, if they diverge, then the image is said to be the virtual image. Hope you know the difference now between the real object, virtual object, real image and the virtual image. And these real images, they can be caught on the screen, while the virtual images they cannot be caught on the screen. So, that is the main difference that you need to know, that real image is caught on the screen, while the virtual image is not caught on the screen. These cannot be caught on the screen. So, they are the basic things that you need to know when you study about the optics. The ray optics, mainly the ray optics. Then we will consider the phenomena of reflection. And all of you have observed that whenever the light is incident on a mirror, the mirror may be a plane mirror or the concave mirror or the convex mirror. And those concave and convex mirrors are said to be the spherical mirrors, because they are the part of a sphere, and about that we will study today. And first we will consider the plane mirror, and all of you have seen the plane mirror, and when the light is incident on such a plane mirror, there is reflection. In fact, there is bouncing back of the light. And that bouncing back of light is called the reflection. And in the next topic, that is in wave optics, you are going to study exactly why there is reflection by considering the concept of wavefront. And in this topic, you are going to study about the refraction and how exactly that refraction is taking place. That you will be studying in the next topic, that is wave optics. So, the bouncing back of light, that is called the reflection. Now, I will consider the plane surface, and this region is opaque. So, whatever the region that you see here, this is actually the opaque region. The light cannot enter into this region, and this is a ray of light which is incident on the plane mirror or the reflecting surface. And the light strikes the reflecting surface, and the light strikes the surface here, which is nothing but the point of incidence. This point at which the light strikes, that is called the point of incidence, and at the point of incidence you just draw the normal. This is a normal drawn at the point of incidence, and with respect to the normal drawn, the incident ray is making some angle which is represented by I, where I is called the angle of incidence. So, it is the angle between the incident ray, this is the incident ray, angle between incident ray and the normal drawn at the point of incidence, that gives you the angle of incidence. Now, there is a bouncing back of light that the light gets reflected, get bounced in this direction, which is called the reflected ray. There is a straight line and there is a direction. The light is being moved in this direction, and this reflected ray makes some angle with respect to the normal, and the angle between the reflected ray and the normal drawn at the point of incidence is equal to R now, where R is called the angle of reflection, Now, experimentally it is observed that the incident ray, one is the incident ray. Suppose I name the incident ray as PQ. PQ is the incident ray, QR is the reflected ray, and this MQ will be the normal drawn at the point of incidence. So, the incident ray, reflected ray and the normal drawn at the point of incidence, all lie in the same plane. So, there is one observation. So, the incident ray, reflected ray and the normal drawn at the point of incidence all lie in the same plane. So, which is the incident ray here PQ, which is the reflected ray, that is QR, and the normal drawn at the point of incidence, that is MQ, all lie in the same plane. So, all these, they are in the same plane, and it is also observed that the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. That is the second observation, and these are called the laws of reflection. They are called the laws of reflection. And suppose the image formation takes place because of this reflection, then the image formed due to the reflection from the plane mirror is always virtual and erect image. If you stand in front of a plane mirror, you observe that the image formed is the erect image, and it is the virtual image. If you are standing like this in front of a mirror, you will get your image in the same way. But there is a lateral inversion. The light appears as left and left appears as right, and there is a lateral inversion, and whatever the height of the object is you will get the same height with the image also. The image height and the object height are equal in the case of plane mirror. And if there is a plane mirror in front of me, and if I am standing at a distance of 1 meter from the plane mirror, the image will be formed at the same distance of 1 meter behind the mirror, and the image is formed behind the mirror. Since it is the virtual image, therefore, the virtual images they cannot be caught on the screen, as we have discussed earlier. The virtual images cannot be caught on the screen because the image is formed behind the mirror in the case of plane mirror. But if I am standing at a distance of 1 meter from the plane mirror, the image is formed behind the mirror at a distance of 1 meter. So, when the reflection is taking place from the plane mirror, the object distance and the image distances are equal. If the object is at a distance of 1 meter, image is at a distance of 1 meter. If the object is at a distance of 10 meter, the image is at a distance of 10 meter behind the plane mirror. And whatever the height of the object is the height of image will also be the same. If the height of the object is 1 meter, the image height is also 1. So, that is about the reflection from the plane. Then we will consider the reflection from spherical surfaces. Reflection from spherical surfaces. So, both are very important here, the reflection from the spherical surface as well as from the plane surface. So, you know the meaning of the word sphere, right? So, if you consider a part of that sphere, then the part of the sphere will act like a reflecting surface. Mainly if you consider the stainless spoon, and when you consider that stainless spoon, and one side of that stainless spoon that is acting like the concave surface, and the other one that is acting like the convex surface. Hope all of you have observed this. If you are not observed, just take the spoon and just check. One of the surfaces is acting like the concave and the other one is acting like the convex surface. And if the spoon is very clean, you can see your image also. In one case, you will get the virtual image, and in other case you will get the real image. And the virtual images are always erect, and the real images are inverted images. So, we will discuss about this spherical surface. Now, suppose I consider a sphere. If I consider a sphere is a sphere, and I will consider only one part of the sphere. Now, I have considered only one part of the sphere, and suppose I have to assume it to be the mirror, then the other surface should be silvered. That means that this surface is opaque to the light, this surface is transparent to light. So that the reflection takes place. And you can complete the sphere also. So, whatever the surface that I have considered here, that I name it as AB, now this is the reflecting surface. Hence, the surface AB is also called the aperture. The surface AB is called the aperture because this much area or this much surface is available for reflection. This much surface is available for reflection, therefore, AB is called the aperture. If the light is incident here, then the reflection takes place. Suppose the light is incident here, then also the reflection takes place. If the light is incident here, the reflection takes place. If the light is incident here, reflection takes place. At all these points, suppose the light is incident, then there is reflection, therefore, that is called the aperture. And in this surface AB, you can consider a midpoint, and the midpoint is represented by P, which is called the pole. So, the midpoint of this spherical reflecting surface, that is called the pole. And you can complete the sphere here. If you complete the sphere, then there is a center for that sphere, is center of the sphere. Suppose you complete the sphere, then C is the center, and that C is called the center of curvature. So, center of curvature is nothing but the center of the sphere of which the given surface is a part of that spherical surface. So, C is the center of the sphere of which the given surface forms a part, that is called the center of curvature, is the center of curvature represented by C. So, it is center of sphere, of which given surface forms a part. But I have not explained what is the concave spherical surface and convex spherical surface. I will explain about that shortly. What is the concave surface and what is the convex surface. So, the center of the sphere of which the given surface forms a part, that is nothing but the center of curvature, and the pole is midpoint of reflecting surface. Now, you can join a line from the center of curvature to the pole, and the line joining the pole to the center of curvature, that is called the radius of curvature. Suppose you have to measure the radius of curvature, then it is the distance from the pole to the center, which is almost equivalent to the radius of the sphere itself. The radius of curvature is almost equal to the radius of the sphere. You can complete the sphere, and this sphere is having a particular radius which is almost equal to the radius of curvature, R. So, radius of curvature is the radius of spherical reflecting surface. So, it is the radius of spherical reflecting surface. spherical reflecting surface of which a given surface forms a part, of which given surface forms a part. That is nothing but the radius of curvature. And suppose you have to measure the radius of curvature, it is the distance from the pole to the center of curvature. And a straight line passing through the pole and the center of curvature, that is actually called the principal axis. So, it is a straight line passing through the pole and the center of curvature, that is called the principal axis. Now, suppose object lies along this principal axis and the reflection takes place, and those reflected rays may meet at a particular point after reflection, and if those rays meet at a particular point after reflection, then the real image is formed, and they may appear to meet at a particular point, and if they appear to meet at a particular point, then the image formation will take place. And here, whatever the surface that I have considered, that is actually the concave surface. The concave surface is a concave surface because the outer surface is silvered here and the reflection is taking place from the inner surface. Suppose the outer surface is silvered and the reflection takes place from the inner surface, then such a surface is said to be the concave surface. Or you can also observe here that the reflection is taking place in such a way that the center of curvature that lies in the center of curvature and the incident ray, this incident ray from a given object, say the object is at a very large distance, and when the object is at very large distance, you will get the parallel rays, and if these rays lie very close to the principal axis and they are parallel to the principal axis, then such a ray is called the paraxial ray. The ray is called the paraxial ray. The ray which is parallel to the principal axis, lies close to the principal axis, is called the paraxial ray. So, when we discuss about the image formation in the case of concave mirror or the convex mirror, we will consider these paraxial rays which are parallel to the principal axis, lying very close to the principal axis. Now, when these rays incident on the reflecting surface, it undergoes the reflection, and the reflected ray that moves in this direction, and the reflection is taking place from here also, the reflected ray would move in this direction, and the rays which are parallel to the principal axis, after reflection they pass through a particular point which is represented by F, and that is called the principal focus. That is called the principal focus, which is represented by capital F. So, what is principal axis? The ray parallel to the principal axis after reflection passes through a point on the principal axis, and that is called the principal focus. So, the ray parallel to principal axis after reflection passes through a point on the principal axis that point is called the principal focus. Then there is a particular distance from the pole to the principal focus, and the distance from pole to the principal focus is called the focal length. Which is represented by small f. So, the focal length is the distance between the distance between pole and the principal focus. Pole and the principal focus, that is called the focal length. And the principal focus lies exactly midway between the pole and the center of curvature. So, we will prove that later. So, that the small f is the distance from the pole to the focus. So, this distance is small f, that is focal length, and the distance from pole to the center of curvature is nothing but the radius of curvature till here. This distance is r, and shortly we are proving that r is equal to 2f, or we prove f is equal to r by 2. F is equal to r by 2, that means the focus is the midpoint of the center of curvature and the pole. And if you observe that the center of curvature as well as the light which is being incident on the reflecting surface, they are in the same media, they are in the same medium, they are on the same side, and such a surface is actually called the concave surface, or the mirror is said to be the concave mirror. Usually the dentist they use this concave mirror to get the enlarged image, or the shaving mirror. There is also a concave mirror because it produces the virtual image, and depending upon the position where you place the object, you will get the real image also. And next we will study the image formation in the case of concave mirror, and where you need to place the object so that you will get the real image, and where you need to place the object so that you will get the virtual image, and so on. We will discuss about that. Similarly, just to know the difference between this concave mirror and the convex mirror, in the case of concave mirror, the outer surface is polished and the reflection takes place from the inner surface. The reflection takes place from the inner surface. The ray parallel to the principal axis, it passes through a point that is nothing but the principal focus. And I will consider the convex mirror. So, in the case of convex mirror, the inner surface is polished. The inner surface is polished while the reflection takes place from the outer surface. So, this is the aperture. If I name it AB, then AB is aperture. Here also AB is aperture because it is the total area available for reflection, and the midpoint of this is the pole. And if you complete the sphere here, here also you can complete the sphere, and when you complete the sphere, the center lies somewhere here, right? The center lies somewhere here, and this becomes the radius of curvature from the pole to the center of curvature. Now, this surface is opaque, is a polished surface, therefore the reflection that cannot takes place from this surface, and the reflection takes place from the other surface. This region is opaque, and suppose the light is incident. The light is incident like this. The reflection takes place, and you observe that this light is parallel to the principal axis. And if you adopt the previous condition that whenever the light is parallel to the principal axis, after reflection it passes through the focus. So, here the light is incident and it undergoes reflection, and after reflection it appeared to pass through a point. It appeared to pass through a point, it does not actually pass through a point, but it appears to pass through a point F, which is nothing but the principal focus. Now, the incident light is on the other side and the center of curvature is on this side, right? And such a surface is, or such a mirror is called the convex mirror. while the inner surface is polished and the reflection takes place from the outer surface, that is called the convex mirror. And this convex mirror that always form the virtual image. And as you travel in vehicle, there is a side view mirror, and whatever the image that you see in that side view mirror is a virtual image, and it is erect image. And in those side view mirrors of vehicles, these convex mirrors are used, and the concave mirrors are used in headlights of lamps or in searchlights. These concave mirrors are used. Hope these concepts are clear. Next, we will consider the image formation in the case of concave mirror as well as convex mirror. Now, for the formation of image, you need at least 2 rays. At least 2 rays are required for the image formation. We will consider those rays. So, first I will consider the concave mirror. The outer surface is polished bed, therefore, the outer surface is opaque, and the reflection is taking place from the inner surface. This is a pole, and somewhere here you have the center of curvature, and here there is the focus. So, we will consider the rays which are used here in the formation of image. One of the rays parallel to the principal axis. Now, the ray which is parallel to the principal axis, after reflection it passes through the focus. It passes through the focus. So, there is one ray that is considered in the image formation of the concave mirror or the convex mirror. You need to remember that the ray which is parallel to the principal axis, always it passes through the focus. And the second ray that is generally considered is a concave mirror, is a pole. Somewhere here you have the center of curvature. Here there is the focus which lies exactly midway between the pole and the center of curvature. Now, the object lies somewhere here, and suppose the ray from the object is made to pass through the focus. If the ray is made to pass through the focus, then after reflection it becomes parallel. It becomes parallel after undergoing reflection. So, that ray can also be considered. And the third one is a concave mirror. There is a pole. Line joining the pole to the center of curvature is nothing but the radius of curvature, and a straight line that is passing through is nothing but the principal axis. And here there is the focus. Now, the ray which is passing through the center of curvature or appear to pass through the center of curvature, there is a ray from a given object. Object is somewhere here, and the ray is being passed through the center of curvature, and the ray which passes through the center of curvature, it retraces its path. The light is incident on the mirror after passing through the center of curvature, and it retraces its path. That means after undergoing reflection, it passes through the center of curvature. So, that is the third ray that could be considered. And the fourth one is a concave mirror. The midpoint of that mirror is nothing but the pole, and here somewhere here you have the center of curvature, and here there is focus, principal focus, and the ray which is directed to the pole, it undergoes reflection obeying the laws of reflection, that obeys the laws of reflection. That means, angle of incidence will be equal to the angle of reflection. And whenever you draw the normal in such cases, the normal drawn at the point of incidence would pass through the center of curvature. So, whatever the angle it makes here with respect to the normal drawn at the point of incidence, the reflected light would also make the same angle. Hence, it obeys the laws of reflection. So, these are the four rays which are used in general. And out of these 4 rays, you can use any 2 rays for the image formation. So, when we draw the image, we will not show all the 4 rays, this and this one. We will not consider all the 4 rays, we will consider any 2 rays. So, the minimum number of rays that is required for the image formation is 2. So, maybe a ray that is parallel to the principal axis, the ray which is parallel to the principal axis, after reflection it passes to the focus, or the ray of light which is passing to the focus, after reflection it becomes parallel to the principal axis, and the ray which is passing through the center of curvature, after reflection it passes to the center of curvature. In fact, it retraces the path, and the ray which is incident at the pole, it undergoes the reflection obeying the laws of reflection. So, these are the 4 rays. So, based on this, we will consider any 2 rays to draw the ray diagram. And whenever you draw the ray diagram, a straight line with an arrow mark is a must, otherwise your diagram becomes wrong. So, will not be considered as a ray diagram, and this is a very important thing that you need to remember, a straight line with an arrow mark when the object is at infinity. So, you have to draw the ray diagram and you need to state the nature of image. So, you know that this is a concave mirror and this is the midpoint, that is the pole, and somewhere here you will have the center of curvature, and the midpoint of this center of curvature is nothing but the focus. And my dear students, whenever you draw the ray diagram here, you fix a distance between F and P, and you draw this focus to be the midpoint. Suppose you take this distance as say 6 centimeter or 8 centimeter, let the focus be at a distance. If you take this distance as 6, let the focus be at a distance of 3 meter from the pole, and if you take this distance as 8 centimeter, let this focus be at a distance of 4 centimeter from the pole. So, maintain that distance so that you will get a better image. Now, the object is at infinity, and as you know that whenever the object is at infinity, you will get the rays which are parallel to each other. The rays are parallel to each other. So, this ray that is parallel to the principal axis, I will consider one more ray that is also parallel to the principal axis. Now, you know that minimum 2 rays are required for the image formation, and the ray which is parallel to the principal axis, it passes through the focus. It passes through the focus. So, these 2 reflected rays, this is a reflected ray, if I name it as 1, 2 and this as 3 and 4. 1 and 2 are the incident rays, 3 and 4 are the reflected rays, and those reflected rays, they meet at a particular point, and if the rays after reflection meet at a particular point, then the image formed is always the real image. So, the image formed is real, the nature of the image is the real image, and as you observe that whenever the object is at infinity or whenever the object is at very large distance, the image formed is the diminished image. The image formed is diminished. You know the meaning of diminished and enlarged. If the height of the object is greater than the height of the image, then the image formed is diminished image, or you can also say that if the height of the image is less than the height of the object, then it is a diminished image, and if the height of the image is greater than the height of the object, then we say that it is enlarged image. So, here the height of the image, which I represented by hi, the height of the image is less than the height of the object, then the image is diminished image, and suppose the height of the image is greater than the height of the object, then the image is said to be the enlarged image. So, that is one ray diagram for the object at infinity, and second position of the object is beyond C, beyond the center of curvature, but it is at the particular distance. So, we will consider the concave mirror. So, this is a concave mirror, and here there is a pole is the center of curvature. The midpoint of this that becomes the focus, and this is a straight line passing through the center of curvature and the pole, which is nothing but the principal axis. Now, I will consider an object AB. AB is the object now, and the ray from the object would move in this direction. I will consider a ray that is parallel to the principal axis. There are 4 rays which we consider for the image formation. Out of that, I will consider the first one, the ray which is parallel to the principal axis, and as you know that the ray which is parallel to the principal axis, it passes through the focus, right? It passes through the focus. Next, the second ray for the image formation is the ray which is passing through the center of curvature. The ray which is passing through the center of curvature. You know that after reflection, the ray retraces its path. So, this is a ray which is passing through the center of curvature, and after reflection, it retraces its path, right. So, these 2 reflected rays, they meet at a particular point, forming the image. So, A dash, B dash. So, the 2 rays, they actually meet at a point. Since the 2 rays are actually meeting at a point, what about the nature of the image? The nature of the image is real. You will get the real image, and if you see the height of the object is this much, while the height of the image is this much. So, which height is greater? The object height is greater or the image height is greater? Yes, the object height is greater than the image height. So, what about the nature of the image? The nature of the image is diminished. The image formed is the diminished image, is the real image and the diminished image, and it is formed between C and F. You know the position of image also now. In the earlier case also, you know the position of the image. The position of the image is at F, but it is highly diminished. But here it is between C and F, and the image is formed between C and F, center of curvature and the principal focus. So, that is image formation when the object is beyond C. Next, third one is when the object is at C, that is at the center of curvature. So, we will consider the concave mirror. The outer surface is silvered, and the reflection takes place from the inner surface, is the center of curvature, and it is the focus, and it is the pole. So, this surface is the silvered surface, which is opaque, and this is the principal axis. Now, the object is at C. The object is at C. So, AB is the object. AB is the object. You know that there are 2 rays for the image formation. You need 2 rays minimum. One is a ray parallel to the principal axis. The ray parallel to the principal axis, after reflection, it passes through the focus. So, there is a ray that is passing through the focus, and you require one more ray So, I will consider a ray which is passing through the focus here. Whenever the object is placed at C, the height of the image and the height of the object would remain the same. They would remain the same. So, this focus and the ray would pass through the focus and the ray which is passing through the focus, this ray would become parallel to the principal axis. The ray which is passing through the focus, that ray would become parallel to the principal axis, and these two reflected rays will meet at a particular point, forming the image. So, this image that is being formed now, and the image is A dash B dash. Now, the image is formed below, and the size of the object is equal to the size of image when the object is at C. So, the image formed is real, the nature of the image is a real image, and it is of same size as that of the object. The size of the image is same as that of the size of the object, and the image is formed below the center of curvature. So, that is the nature of the object. Now, if you analyze these three cases, in the first case the object was at infinity, and when the object was at infinity you got the diminished image, and the image was formed at F, that is at the principal focus. Next, you brought it closer, you placed it just beyond C. When you have placed it just beyond C, you observe that the size of the image increased. Now, in the third case, you placed it at the center of curvature, and you observe that the size of the image is more than that of the first and second two cases. And what would be the fourth case? In the fourth case, we will place the object between the center of curvature and the focus. So, that is the fourth case, that is the object placed between C and F, that is between the center of curvature and the principal focus. So, this silver surface, and there is a pole somewhere here, there is a center of curvature, is a center of curvature, and somewhere here you have the focus. Take care to see that the distance, whatever the distance is there from P to F, same distance is there from C to F also. Now, the object is placed between C and F. So, I will place the object between C and F. So, this is the object AB, and one of the rays parallel to the principal axis, a ray parallel to the principal axis, after reflection it passes through the focus, right. It passes through the focus, and another ray is passing through the focus from the given object. The ray which passes through the focus, it becomes parallel to the principal axis. So, this is the principal axis. Now, these two reflected rays, they meet at this point. The rays are meeting at this point, forming the image of the object A dash B dash. Now, if you observe this diagram, the size of the object is this much, while the size of the image is greater. Size of the object is less, while the size of the image is greater. So, what type of image do you get? Do you get the diminished image, or do you get the enlarged image? Yes, it is the enlarged image. So, the nature of the image, is it real or virtual? real image. If the rays after reflection, if they actually meet at a point, then the image formed is always a real image. So, the image formed is real and is inverted upside down, right, is inverted image, and it is enlarged image, and it is enlarged image. And in the previous case also, is the real image is of same size, and the image is formed below C, and it is inverted image also. The image is inverted upside down. And where the image is formed? Image is formed beyond C. The image is formed beyond C. So, what happened to the size of the image? Size of the image has increased as you move the object from infinity here. We will move it further. And we will place it at C, that is at the center of, we will place it at F, center of curvature is over. So, we will place it at F, that is the principal focus, that is the fifth case. So, at F is a concave mirror, silver surface, and this is the pole. Somewhere here you have the focus, and somewhere here you have the center of curvature. Now, suppose you place an object at the focus. So, AB is the object, and one of the rays parallel to the principal axis, a ray which is parallel to the principal axis, after reflection it passes through the focus. And we will consider one more ray which is being incident at the pole, which obeys the laws of reflection, and when it obeys the laws of reflection, whatever the angle of incidence is, it makes the same angle. And if you observe these two rays, what about the two rays? The two rays are parallel to each other. Since the two rays are parallel to each other, they do not meet. Therefore, the image is formed at infinity. The image formed is at infinity. We will consider the last case of this, where the object is placed between F and P. Object between F and P. Object between F and P. So, we will consider the concave mirror. Then there is pole, is center of curvature, somewhere you have the focus, and the object is placed between F and P. So, AB is the object. One of the ray is parallel to the principal axis, the ray which is parallel to the principal axis. After reflection it passes through the focus, it passes to the principal focus. And another ray, we will consider the ray that is passing through the focus here, another ray from the object that passes through the focus as being incident here, then it passes through the focus. Now, these two rays, when they are produced in this direction, when these two rays are produced in this direction, they actually appear to meet at this point. When they are produced, they appear to meet, forming the image of the given object, that is A dash B dash. So, when they are produced, they appear to meet. Since they appear to meet, what about the nature of the image? The nature of the image is virtual. And what about the size of the image now? Size of the image is greater than the size of the object, therefore, it is enlarged. before it is enlarged. And whenever you visit a dentist and if he uses the mirror, he uses that mirror in such a way that the object lies between F and P. So, hence you will get the enlarged image, and here it is the virtual image, because the rays are not actually meeting. Since the rays are not actually meeting, the image formed is the virtual image. So, that is about the image formation in the case of concave mirror. Thank you.